Good evening, everyone. This session today will continue from where we ended last month. Last month, if you remember, we talked about the artificial intelligence in general. We discussed types and the implementation, which industries can the artificial intelligence implemented. For this session, we will choose one of the artificial intelligence practices. It's called intelligent systems. Intelligent system is a form of systems that can be implemented within the medical healthcare or within the stock market. It's sort of expert systems in a form of identifying the expertise and knowledge from any expert domain and extract this knowledge, encode this knowledge in a form of data, and the systems will try to imitate the human actions. So that means the systems will do the same decision making similar to the experts. Okay, so let's start with these things. I'm not sure about the people who attended last month. So we talk in general about AI. So today we'll focus only on one of the implementations. We will try to explain it first, and then we will implement it. We'll try to develop an intelligent system which can identify possible virus infection. Okay, so first, before I start to develop the system, I'll just introduce what we mean by intelligent systems. The first, we'll talk about the concept of intelligent systems and how to build a rule-based expert medical systems. Okay, so I'll talk first about the intelligent system. What's the intelligent system? It's about expertise. You know, everybody have when you talk about the domain experts, it consists of knowledge and experience. So if we need to take any decision, and decision will be considered intelligent decisions, will be based on two things: our knowledge and our experience. Combine these things, two areas together, we will have some sort of intelligent decisions. Intelligent decision, which means will be accurate decision, whether it's to solve a problem or capture an opportunity, these things. So the aim is to see how can we transfer this action, this decision making, or this recommendation to the machine, how the machine can use the same process, which means we'll try to encode the knowledge, the experience of any expert into the machine, and the machine will try to take the actions. So it's about knowledge, how to deduce some sort of reasoning and take intelligent decisions. So definition of intelligent systems operate over a structured relational encoding of contents. They often take the form of list structures, which enables to encode logic and logic-like relationship. It's based on logical reasoning. So which means it will consider the decision will be taken based on the data provided. Whether the data is it correct or wrong, the system will consider it true because it's based on logical reasoning rather than abstract form of intelligence. So it will not sense and verify this information. It just will consider this information is true, whether it's true or not. So, however, considered intelligence because the same decision, similar to the expert body of knowledge, will take a decision. Okay, so this is the definition of intelligent system. Rule-based expert system. What the meaning of expert system? Expert system in a form of trying to identify a very niche identification, very specified, very specialized system will focus on a certain area. It's a computer systems that emulate or act in almost all respects with decision-making capabilities of a human expert. So this is what we will try to develop this afternoon. The components of a rule-based expert system. First, look at the knowledge base. Knowledge base consists of two things: the knowledge, theoretical, and the experience of anyone have a knowledge, theory, and experience. Combine all these together, we'll consider it as a knowledge. And then inference engine. Inference is a form of taking action, taking decisions. So will perceive a certain, the system will develop a certain perception from the knowledge choose and will perform a certain action based on the structure of the data we provide. And then how to deploy these things in a user-friendly interface, such as API or whether it's a cloud computing. Okay, so a domain expert human, if we look at the definition of the expert, the human, it's a field of experiments, a combination of theoretical and practical, will try to transfer these into form of logical reasoning to the system. The system will try to imitate the behavior of the expertise. It consists of a long-term memory and short-term memory. Usually the experience we take it through time, it will go to our unconscious mind in a form of long-term memory, and then we'll try to build these things through time by adding knowledge and experience, and this knowledge will grow in a way that our decisions will be more intelligent through times. And these things will be set through different rules. For example, any decision I will take will be based on these areas. So usually it will be based on a certain environment. Let's say, for example, here, I'll explain it. Let's say, for example, this is the environment. Environment means the area surrounding any decision. It consists of maybe, for example, I need to take a decision about to choose something or to take a decision, any form of decision to contact a certain supplier or to choose a certain customer, or any decision making. It will be based on two things: the current events happening with me in a certain environment, for example, interaction, communication, meetings with certain people. So these things will be perceived through my unconscious mind based on the knowledge and experience, and these will help me to take the intelligent decisions. So the input of a certain environment will be based on many factors. He will as a human, will develop some sort of abstract intelligence to sense and verify any information we get from the environment. Whether a meeting, whether a communication, whether a evaluation, whether a report, etc. And we perceive these things, and we take a decision. This is our action. So our action is supposed to be intelligent because based on these things. We're trying now to delegate, let's say, these information, the input, which consists of knowledge and experience, to the system. So the system will take the decision, exactly the same like a human. Take a certain decision. So we need to develop, we need to transfer these things. So we need to encode these things in a language, let's say, that the system can understand it. And we set the certain rules, certain logical conditions. If, for example, a certain symptoms appear, this is the action we need to take. So it will be based on a decision-making or a decision tree analysis. So the system can be made either through Boolean logic, for example, yes or no, true or false. It will be very basic and simple, or it can be complex using fuzzy knowledge. For example, identifying many factors combined together will be very complex system. But today I'll just use the simple one based on Boolean logic, whether it's true or false. So this is how the system can consider be intelligence. However, if I will my input data into the system will be wrong, the system will take wrong decisions, because the system form of intelligence based on logical reasoning, as I mentioned earlier, it will consider the data is true, whether it's true or not. So it's still dependent on my data input. So that's why it's a rule-based form of intelligence. Now, as I explained last month in previous session, that there are different types of artificial intelligence. Object-oriented form of intelligence, it's related to machine learning, for example. Using Python language, we try to identify a certain observation from an environment. If we have a big data, so it might be difficult for a human to identify a certain trends within these data. So using machine learning algorithm, it will help to generate a better observation of these, and they will take better decisions. This is another form of artificial intelligence. This type of artificial intelligence based on logical reasoning is totally different from the other form of intelligence, but it's very useful for expert knowledge. It will help me to extract all the details, all the expertise, all the knowledge from any expertise and add it to the system, and the system will generate similar decision-making, exactly like expertise. Now, what's the benefit of this one? It will help the healthcare industry to facilitate the interaction with users, for example. So instead of for me of going to the hospital or to the clinic to check something, I just use the system, and based on the system, there will be a certain recommendation to go. So it will be user-friendly, and it will help the industry to be automated, the form of digital transformation. Okay, so it's the knowledge is based on a long-term memory and a short-term memory. Now the thing is, this concept is long time. It's not a new concept. It's very old concept, maybe in 1950s and earlier. But I think the processing power at that time was very low, especially the GPU processing power. But currently, with the processing power is let's say adequate for a certain level of narrow artificial intelligence, so it start to be used and we start to see its impact on industries in certain areas. Now, this is how it happens. Now, I will transfer the knowledge. I will start to extract the knowledge from expertise. Now, it could be the knowledge expert, maybe regarding the stock market, stock broker, maybe, for example, or within the healthcare industry. Whatever, any type of expertise. So we'll extract this knowledge, and the encoding of this knowledge will help the system to identify what decision needs to be taken based on this knowledge, and then we will use our recommendation system to advise any user. So let's say, for example, if this is a non-expert user trying to use the system using a certain user-friendly API, for example, the user of the system will not know whether this information is coming from a real human or a machine, but at the same time, is taking or she's taking the same results. So the advice will be taken. So it will have a query and then the advice. So this is what we call an expert system. Now, to make it better also, expert system can be augmented with other form of technologies. For example, if I develop an expert system for possible to diagnose a certain possible virus infection. So this is intelligence system number one, for example. It will be rule-based. It will not be able to interact independently or autonomously because it will be based, the objective or the decision taken will be based on my input data. So it will be a very narrow system. And with the specific, very precise objectives for a certain area. Now, I can add different types of technology to develop another, let's say I develop another system. Let's say, for example, this system, for example, in manufacturing area, let's say we are manufacturing a car. So I will develop a system to be able to develop part of this car, for example, the interior design. Now, I will develop another intelligence system to start to assemble these things. So this is, for example, it has a certain objective, and the other system had different type of objective, but it's supposed to work together. But the thing is, they are not interacting with each other. So introducing different different types of technology, or augmenting other types of technology, such as Internet of Things, it will help me to these systems start to interact with each other. By interacting with each other, those systems will start to be called an agent. So agent 1, agent 2. Why? Because the system will be able independently to perceive the external environment and develop a certain perception and take a decision independently. Why? Because I augment it with sensors and detectors. So I use different form of technology to help facilitate or make the implementation of AI more tangible. So agent 1, agent 2 will start to interact with each other. So we'll have one objective, another objective. I might develop another agent, number 3, maybe taking care of another form just to develop a certain process, maybe manufacturing a car. Now I need to maybe to use a certain robotics. Maybe I will use with engineering, with the help of engineering and motions to help me to apply these AIs and other form of technology to make it more tangible. So objectives have another objective, agent number 3. So it looks like those will start to work as a team, which have a common objectives to manufacture a car. And they will work independently, totally independently. Why? Because I use a certain form of code or algorithm to help the systems identify a certain input, take observation from the input environment, from the external environment, perceive these, and take a certain action with a very precise objectives. So if they work together independently, so there will be an owner for this system. That's why the system will call an agent. Agent, he's acting. So agent 1, agent 2, agent 3 is called a multi-agent system. Multi-agent system. So that means what I'm doing, I'm going to do now is to develop one of these agents, but it will not be an agent because I will not introduce or augment IoT or Internet of Things or other sensors or detectors with it. It just will be a rule-based expert system, but it can be developed with other systems. Augmenting all these together, we can automate a certain department. We can automate a certain process. We can digitize the supply chain. We can use it in many areas. So that's why artificial intelligence usage combined with other form of technologies can really be tangible, can be implemented, and can be seen as intelligence taking independently, taking decision independently, and interact with each other in a form of a teamwork. But this is will not discuss all these details now. I'll just develop a small intelligence systems to for healthcare industry. Okay, so now what type of system, what type of language we'll use, what type of syntax? There are many things, but usually for intelligent systems, I will use a language called Prolog. It's a logic based on the logic reasoning rather than object-oriented. So I will not use Python. Python is for different types of intelligence. Some trying to identify and generate presentation from the environment. Here are trying to extract the knowledge from a certain expertise. So what I need to do now is to develop an expert system to diagnose a possible virus infection. Now, when we talk about a possible, that means will be form of a decision making. That means there will be a certain symptoms. One, for example, temperature, for example, high temperature, for example, coughing or something. It will be, this is not, we will identify what are the root cause or root causes for these things. Root cause 1, 2, 3. So who knows these things? The expert. Based on what? Based on the knowledge and experience. So I'll try to extract the knowledge and experience and encode these things to the system. The system will be able to identify based on a certain set and take a decision. So this decision the system will take will be similar to the expert knowledge. So the system will consist of a knowledge base and fact base. Knowledge base, which means the area, a fact base related to every knowledge, what decision I need to take in case I got a certain knowledge, and the main fact of the recommendation engine. So the system will try to deduce new facts and set recommendation for the users. Okay, so now what we need to look at the knowledge base. So first thing about the possible virus infection, we will identify what type of knowledge we need. So it might be categorized into 3 areas: symptomatic, asymptomatic, and the old people, for example, let's say. So first, most common symptoms, less common and serious, and then we'll look at any contact with virus carrier in the last 14 days, more than 14 days, and we'll look at so from where we got this information, from the subject matter experts. We don't know these things, we will just get this information. So the fact-based, because most common symptoms will be based maybe on fever, persistent tiredness, sore throat. Less common symptoms will have headaches, running nose. Serious one will be difficulty breathing, chest pain, loss of speech or movement. So how we know these things? Again, this is from the experience and knowledge from the subject matter expert. Other types will be probability of virus contraction, maybe close contact with infected person within the last 14 days, touching infected surface within the last 14 days, probability of no virus contraction, close contact with infected person with more than 14 days, or touching infected surface with no signs more than 14 days. So that means we will look also at the other fact base in case maybe we can change it from age 70 to 60. We can use based on we can change the knowledge and data based on the new development. So, and like these are vulnerable individuals will be divided into 2: patients with pre-existing health and old people. In case pre-existing health, hypertension, diabetes, these things. Now, the system I will develop will be based on a Boolean logic, which is either true or false. That's it. So it will not be complex, but can be more complex because things are interrelated with each other. So it will not be that much accurate, but this is just a sample one I'm developing. This one will be more using a fuzzy form of knowledge. Okay, I'm trying to encode the knowledge. This is the knowledge. I'll share with you the system. So this is I'm trying to encode. So I encoded now the knowledge and I put it in the form. So here, I'll try to give instructions, what we need to do, what's the patient name, etc. This is the symptom. For example, if in case the patients have fever, yes or no. Here, symptoms 1, persistent dry, yes or no. These are the symptoms. I encoded. And then this is the knowledge base. So I'll divide it into first one. If most common one, fever, persistent dry, and tiredness. Second one, it will be coded into diagnostic number 1, the most common one. What the recommendation the system will generate in case the patients have fever, persistent dry, and tiredness, the system will recommend further checking is needed. Check diagnostic number 2, less common symptoms. I can change it. if I give a wrong information, the system will generate wrong information. The system will be dependent on me to give different information. But I said before that I can develop the system to be independent later on. Other one, so in case the system will start to look at these things. In case the patient doesn't have fever or persistent dry or tiredness, we'll start to ask different questions. We'll go to the other one, number 2, the less common one. So we'll check these symptoms, and in case they have some or not all, then further checking is needed. Why? We need to check number 3, serious one. Why? Because the system will try to make a better recommendation, try to check everything. So number 3, serious one. This is in case the patient tests positive for this one, then the system will generate immediate action needed. In case you got difficulty breathing, chest pain, loss of speech or movements. Now, in case the patient doesn't have anything of these, the system know that will jump to another area. We'll start what's the age of the patients. In case it's 70 or above, then we'll start to ask more questions. Pre-existing health, for example, do you have these things? If no, then we'll jump to another one. Which one? This. Do you had a close contact within the last 14 days? Suspect touching infecting surfaces within the last 14 days. If yes, then we'll generate recommendation. If not, then we'll check another one. You had a contact with above 14 days or not. So based on these things, this is a very simple one. And then the system will start to generate. Let's try it, how it will work. Just 1 second. Just to extract the system data. Okay, where is it? That's it here. Just give me a second. I'm just to open the system. Okay. Okay. That's it. So this is the interface. I'll try to now to extract the data and start to see if it's working or not. So the first thing, what's the name of the patient? For example, this is the name. This is the first question. Does Gilbert have a fever or not? Yes. Does Gilbert have a persistent dry? Yes. Tiredness? Yes. This is the recommendation system will be generated. So what is this? Exactly how I instructed the system to do. If I change it there, it will be changed here. So for example, Gilbert probably has number 1, most common symptoms. Further checking is needed. Check number 2. Okay, so this is the recommendation system. We'll try to check number 2. Okay. So number 2 is this one here. This is not. So the first question we will ask is this one, because we jumped from here to here. For example, if we meet everything, so diagnosing number 2, less common symptoms, further checking is needed, check the serial one. Why is doing like this? Because I instructed the system to do like that based on the knowledge I got it from the subject matter expert. Now I'll try to see the other recommendation. Please try to skip this one and try to the third one, have a chest pain. So it's a serious, so that means this is the recommendation we got, immediate action needed. Now let's continue more in case there is a different results. For example, if I don't have this one, then we jump to ask, what's my age? If my age is above 70, yes, then we'll start to ask more questions to clarify it. You have pre-existing health, yes. For example, let's say I got all these, but I mean, you will have everything, so that means immediate action is needed. Again, I will try different probability. This one. Yeah, same thing. For example, if I have nothing, the system will start till the end. So no sign of virus contraction. However, please visit your nearest healthcare center. So many options, many generations. But if you look at the system, it's not a user-friendly. Just we're developing this one. This is back-end things. So to make it user-friendly and to make it more accurate, we need to introduce some sort of fuzzy knowledge. What the meaning of fuzzy knowledge? In case you have a fever for a certain level, but at the same time, so we'll try to interact different groups of area of knowledge together. We'll make it more complex. It can be done more complex, but just this is for illustration only. So that means if you look at this information here, the knowledge, this is a summary of the knowledge and experience of the results of the healthcare industry in a certain area. So the system will be able to do the same thing. What's the benefit of this one? If we develop a user-friendly interface and instead of going for me to hospital, I just use it, it can save time and it can save me, save the healthcare industry staff more time to focus on something different or many benefits. This is very simple, but it can be more complex than this one. Okay, so this is the knowledge. So I encoded the knowledge. If you look at these things here, it's based on knowledge base, fact based, and the recommendation. This is what we did. So the knowledge base, we might identify more or less. We can change it, depends on the development. Okay, so this is how it works. Now, how the system works, you can do, depends on the subject matter as what we'll tell you. For example, in case he will got the in case the patients got symptomatic most common symptoms, for example, yes or no. If yes, then whether yes or no, we need to check most common and less common. If yes, immediate action needed. If no, then go further to check serious symptoms. If yes, also immediate action needed. If no, then we need to check the age, if it's above 70 or not. Again, if yes, and have something immediate action needed. If no, then until the end. So it could like no signs of virus contraction. So this is how we set the rule. That's why it's called rule-based. And why it's expert? Because it's based on a knowledge expert base. Now, it is very simple, very logical, very simple coding language, but very effective. Why? Because it can be used more different types of, because this is Boolean logic, whether true, yes or no. We can use, as I said, the fuzzy form of knowledge, what that means, because we can have a, we look at the probabilities of everything and mix it things together. The same thing, we can use it, we can develop it better, we can have a more accurate results. So this is an example of what we did now. Now, this one, it has to deploy it. How the deployment? Through either application programming interface, interaction between two programming computer programs, or graphical user interface, interaction between the system and the human. And this one, usually it's used at GUI, graphical user interface, because it will be used with interaction with the human. All these can be implemented, also deployed to cloud. This is an example, for example, how to deploy this one. So what we saw now, it will be better in a better user friendly. So you just write if you have fever, yes or no, and click on this one, and you will get the results, the recommendations. So this is the inputs. The inputs, if this is what we mentioned here. It's very messy. It's not a user friendly, but this is just the algorithm. But it will be very easy to be used, very well. It can be used either we deployed, whether it becomes streaming online, whether in cloud computing, or whatever it is, so any user can put the information input, and will get what the output needed. Yeah, it's just a very simple illustration of how the artificial intelligence can be used with a simple coding, with the simple illustrations that really can help and facilitate the automation of, for example, this in health industry. It can be also used as different, but this system, for example, I can develop another system. Let's say, for example, after the patient has been diagnosed, you need to use something else. I might develop another system and use different form of technology to augment, for example, pervasive technologies such as IoT or other things, which will help me to integrate these things together. But I need to make it more complex to be able to this system will be independent. Now the system is still not independent, so I'll use different form of language. It's called JSON, for example. So that means currently AI is still narrow. It's not deep. It's not sorry. It's not general. It's not super AI. It's just very narrow AI. It's very for specific things. Whether is a autonomous car, whether is a computer vision, whether it's a sentiment analysis, identifying sentiments in social media, using deep learning, still narrow. But the thing is, because the processing power is high now, and there are different forms of technology, it can be augmented with AI, then it can be tangibly employed in every industry, and can be used and benefit and it will help organization or other things to digital transformation or automation of its transformational process. Okay, this is just a small illustration of how the systems work. This one is called rule-based expert systems. Rule-based expert systems, because there is certain knowledge needed. Based on this knowledge, I can identify the action needed. And it has to be based on a certain rule. So that's why it's called logical reasoning system. As I mentioned before, the system will consider this knowledge as true, whether it's true or not, because it's based on structure only, rather than abstract form of intelligence to sense and verify these facts. But if I augment it with other types of technology, the systems start to not using abstract form of intelligence, but start to be more independent, start to verify, let's say, and perceive the input environment and start to take decisions and take a decision independently. Then the system we'll call it then agent, because the system is taking decisions based. There will be an owner for every agent and responsible. Now the thing is, when you start to develop these things, who will be responsible? That's the thing. That's why new rules and regulations being developed, such as ethical AI, such as, okay, for example, we developed three or four intelligent systems, agent, they're interacting with each other. Is any small mistake, who will be responsible? So that's why when things change, also new compliance, new governance, organizational governance has been start to be developed now to ensure that responsibilities, because sometimes it's vague, so it's not known who's the software development or the AI specialist or the owner of the system who will be in charge. Okay, if you have any question, anything to clarify, please let me know. Okay, if you don't have any more questions, then we'll end the session now. This is just a small illustration. I'll just share with you the poll. But at the same time, if you have any question, any clarification, how to use this one, what type of system I'm using, fine, I'm ready to answer.